Okay, so this is the 2020 DEB mock junior cert paper. So I'm going to go through question 1, the orthographic question. So first things to notice when looking at the question, no harm doing a little sketch before you start this question, just of how it's going to develop. For instance, we're told to project an end view in the direction of arrow B here into the right hand side. So when we project into the right hand side, the end view is going to be projected out to the left hand side on our drawing. So that's my elevation there and my plan, and then that's going to be my end view over here. So I'm going to use this as my starting point, and I'm going to work my way across. I'm going to put in some measurements. As I said in other questions, I'm going to go through this slowly and explain different concepts, and you can just drive on, skip to the part that you're stuck with, and so on. Just another thing to note, the top here, it seems to be starting off narrow and then gets wider at the bottom. So this surface here, those lines seem to be parallel to each other, and this surface here seems to be parallel. So it looks like this here is going to be jutting out, and our surface S here, the wings of it almost, are going to be jutting out as well. So we're probably going to have to project an end view first before completing our plan, to find those widths at the top. So we'll go ahead and start off and draw our elevation first. So first thing to note, the height of the overall thing is 92, and the overall width 48, 77 is 125, and 44, so that's 169. So I'm going to come in about 180, give yourself plenty of room, and come down about 100 off the top of the page. Okay, I'm just going to stick up this question for me. Okay, so the overall height 92, so we're going to come down about 200. What did I say? No, sorry, 92, so we're going to come down about 100, 110. That should be plenty. I'll just draw a horizontal line there, nice and light. And the overall width we said was about 169, so if we come in 200, maybe that should be fine. And I'll just draw a vertical line there. Okay, so elevation is going to be here. 92, yeah, there was room. Okay, so put in some measurements. So working from the bottom across, 48 is our first one, 48, and 77. So as I said previously, you guys don't need to wait for me, you can drive on and don't have me slowing you down. And then 44 is our bottom, so that's the radius in the bottom right. You'll see that R44, so that just means it's another 44 out, and it's going to be a curve. Overall height, so I'm going to use this one because it seems like this one is the one with the height 92 on it. So step up 92. So that's coming in another 77, that one. So up to 92. And that juts out in our 15. What we do is I pop a little horizontal line there, so I'm not measuring on thin air. Okay. Just get the focus perfect, right. And measure out another 15. Up here. Lovely. And what we can do is we can join that down to the bottom, because we know that's the extreme right hand side. Okay, so that's that bit completed. We came in 15, we know sorry, to come in another 17. There. That's a little vertical line there that comes down. Will that look vertical? Yeah, well, and that comes down 8. So we can measure down 8, there's 9, there's 8 there. And that's a horizontal line for 52, but instead of measuring, I'm just going to draw a horizontal line first, and then measure 52 on it. There it is there, 51, 52, yeah, perfect. Okay, the next part is our surface S So that's where we are. We're working our way across the top of it now. Excuse me. So 16 across. So I'll just measure across that 16 first, and then measure down the way. So there's 16. So that's our original marker. To make that a bit bigger. So there's our 16, and that has a vertical drop then of 12. Okay. 12. We're not far off it. Yeah, there we go. And then that just finishes it out to the end. That should be 40. Yeah, bang on. Right. Good start. Okay, so the front part here, 48 is the width of it. So if we just measure in 24, that should be the center of it. And a vertical line there to measure up the 52. 52, and we want to pop in the radius here of 18. So I'm going to measure it first. 17 and 18. Use your compass, of course, to construct this because it's just a semicircle. Okay, so I'm going to go over it a couple of times with my compass so you can see it a bit better, whereas obviously you don't need to do that. Sorry. Right. And that goes down to the bottom wings then. So as I said, guys, anything in red is construction. Anything in blue, I rarely use blue, but when I do, it's only instruction. You don't have to put on your sheet. And then black is obviously anything in heavy. Sorry, I forgot to complete surface S up here. So I'll actually show you that, how I worked that out. So I came in 16 and measured down 12 mil, and then you can just join them up. Alright, so this is when I came in 52 that way, found that point, and that's your surface S there. Alright, so that's very important. That'll be very important down the line. That's our surface S. Alright, so that's very important. Moving on. Okay, we're going to construct our plan. Right, so our plan should be 20 mil below. Should be plenty. So I'll just pop down 20 and horizontal line. We know the full width of it is, so it's kind of slanted, but if you look at the very bottom, we're going to work with the radius 44, so that means it's going to be 44 either side of the center line. So from there I'm going to pop in 44, and I'm going to pop out 44 the other side of it. So I'll measure that 44 now. So there it is there, right? And that's just going to be the center there, and that's my 44. Next thing, I'll bring all my important lines from my elevation down. Now notice how I go away from the last thing I just drew, so don't go back over yourself almost. Okay, sorry, I know I just did it there, but try. When you draw a line, try work away from that line you just drew. So I just drew a line here, so I'm going to work that way. Alright, I'm not going to go back over myself. It just reduces the risk of smudge, alright, because it doesn't look nice on our drawings. And then that's our last radius there. And we'll find that, no bother ourselves that one. Alright, so the only real width I can put in here is that radius 15. At the top. Alright, so that's the only real width we know, because it kind of looks like it widens as it gets to the back of it. So the only real width we know is that 18. So what we're going to do to help us is we're going to draw the end view. Alright, we're going to draw the end view, and that'll help us find those points on that slanted edge. So as always, pop off at 45 degrees from our elevation and bring all the widths from your plan across. And bring them vertically up then as well. You can actually bring this 18 across. Is it? No, sorry, it's 15, isn't it? Yeah. So you can bring that across. Because that's the only width we're aware of. And if you look at the question, that's an important surface because we know the bottom goes up to that surface. All right. So I'm going to bring that across as well. So next thing, sorry, bring our heights across. So bring all your heights across. As I said, anything red is construction, so that should be nice and light with a sharp pencil. Okay, you should barely see it. And you know what, I'm going to leave that little bit jutting out at the front to last because there's a freehand curve in it and I don't want to put too many lines on the page just yet. Okay, just to make it a bit clearer for you, I'm actually going to put in as much of the elevation in heavy as I can because it's starting to look very red. Right, I want you to be able to differentiate between the elevation and so on. Okay, so I'm going to try to draw as much as I can. So I'm going to put in all my vertical lines first. Okay, and I'll work with my horizontal lines. So watch how efficient I'm trying to be with my lines. So I'm doing all my horizontal lines together, vertical lines together, and so on. And then the other lines then that are angled, you can just go ahead and do them last. Okay, so you can start to see the drawing come together a bit better now when you're using the different well, I'm using different colors, but when you go on heavier, you'll see the part of the drawing that you want to stand out will stand out. Okay, so you can see my elevation right there. Plan, I don't have much of it yet. Okay, so we're going to try do some of this end view. Okay, so we're looking in direction of arrow B. So if we're looking at a question right now, if we're looking in direction of arrow B, the first thing you're going to see is this curved surface. Okay, you won't actually see a definite line, so it'll just be the curve. But what you will see is the extreme left hand side and the extreme right hand side will just be represented as a line. Okay, so that line, basically, we need to find it. But if you were to draw it here, you would say we need to find it some way like that. Okay, sorry, it should probably be something like this because it's almost like a cone at the front of our drawing. Okay, so that curved surface there is almost like a cone, and you know if you look perpendicular at a cone, you're just going to see the left and right hand side of it. Okay, so if I was showing you, if I was to extend that on there and extend that on there, there you go, you can start to see the cone come together. So what we need to find is this left hand side and the right hand side, and we know they both join to that height there at the top. So what I did there is this height here is that width. Okay, and we know it joins to that, so I brought that up, and I can similarly do it down here, bring that across and up. Okay, and that's our extreme left and right hand side. And looking at our question, yeah, we can go ahead and put that in heavy. Right, these are two important lines that help us find the widths in our plan. Perfect. Right. And then the top will just be a horizontal line here. Okay. Now to find our widths. Okay. So this is where the extreme left and the extreme right of this surface of this object will come into play, because see these edges here, we don't know the width of those in plan. But the end view will allow us to find that. So by projecting across here, when we hit that slanted surface, we bring those down to our plan, and that will help us find them. Alright, so those that I brought across to our end view, I'm just going to bring them into our plan. And you can bring them across then. Okay, so that's this surface here that I'm trying to find. So this middle surface here. So I'll show you here. So what I'm trying to find now is this surface here on top. Okay, so that surface, the red surface there on top. Okay, so the width of it. So I came across here, and where it hit that slanted surface, I'm actually going to put that in. It's actually hidden detail because it's behind. So you can put that in there. So that's hidden detail there. And when the surface comes down, there it is there. So that means that has to jut out. So here it is here. Alright, so this is probably one of the trickier parts of the question, as it's just hard to visualize. Okay, it's just a small bit tricky to visualize, and that's jutting out that way. Okay, so we're starting to make some progress. Alright, so that's one of the trickier parts of the question, is just trying to visualize that surface now. Right, surface S. Okay, so we brought our height across, so surface S starts here and it'll actually expand out. So we need to bring those down from our end view and into our plan. Right, that stops there. And here's surface S being completed now. So that's surface S, I'm just after finding here. So that's the very important surface. So we're going to be asked to find the true shape of that surface later on. And then the last bit, you can see it there. So it's actually hidden detail again. So that's the back of it. So you'd see it's that width. So we can just draw the two horizontal lines in. Alright, so that's very tricky, that bit, trying to visualize how it actually works out. And then the back of it is just a straight edge, so that can be just vertical line. And I'm going to put in that curve at the front for us. So that should be 44. There it is there. Goodness, am I after? Are they on the same center point? They are. Lovely. Alright. So that's 34. Just make sure we're accurate. Okay, so that's the plan almost completed. And there's the 44. And you know what, I'm going to leave that bottom part for a second because there is actually that bit jumping out at the front, so we'll put in that now. So what we've done so far just to take a little recap, just to check in with you. So if the elevation fully completed, the plan is not fully completed yet. We have to do this bit jutting out the front, and there is a freehand curve. So if we just look at show you, if we look at our question again, the freehand curve is there. That's what I'm on about. So that's the freehand curve I'm on about. Alright, so the way we find that is by 60-30 in our elevation and bringing those points to our end view and then relocating them in our plan then. So we're going to go and attempt to, yeah, we'll do that now. So first things first, I'm just going to see how, I'll do the front bit that juts out. So that juts out 16 mil. So measure along a line, 16 mil, extend in that bit more. That's not what I should draw, sorry, and that one. And this one here as well. Okay, so that's basically the front edge there. Goes, first look at our plan, you see it all, there you go. And then that juts straight back into the 44, and then that extends on out there. So what we're missing now is this freehand curve here. Alright, so there is a freehand curve there. Right, how do we do that? I hear you say. Firstly, actually, I'm going to complete this end view. The bit jutting out with the end view. Extend that across, bring that out off it, and that as well. So now we need to find this freehand curve. So we're nearly there. 22 minutes in, we're going well. So I need to 60-30 that semicircle in my elevation. Alright, sharp pencil is key here now, because you'll see there's a lot of lines starting to come together on the page. So this is where it's essential to have a sharp pencil and that our construction was nice and light, so we're not confusing ourselves. Okay, so I'm going to number these points here. 1, 2, 3, 4, and 0.5. Bring those across to our end view as well. And what we'll do is we'll number them on our end view as well. So here at the top is 3. That's if we were to look in, then that's going to be 2 and 4 are going to be on this. 1 and 5 are going to be here. And then down the bottom, we'll just say that's O. Let's say, alright, so that's O. So center O. Okay. So, sorry about that. Here we go. So, we're going to bring down our points as well into our plan. Alright, so there's 1 brought down, 2, 3, sorry, I should be extending them a bit more. 1, 2, 3, there's 4, and 5 is actually on another line we have already, so that's fine. Right, so we need to bring these down from our, so what I've done there so far, 60-30 my elevation, the semicircle, numbered my points, brought them down. Brought them across to my end view, and now I'm going to bring them down from my end view as well. So there's, do we need 0.0? We'll bring that last. 1 and 5 are going to be on this line, 2 and 4 this line, and then last but not least you're going to have 0.3. Alright, so sharp pencil is key here, guys. You'll see. Do you know what? We do need 0.0 because that's where the two left and right extremities are. Lovely. Right. So 3, 2, and 4. So let's say 3 is that one there. And 2 and 4. 1 and 5. And then O is the last one. Okay. Okay. So we'll start numbering them. I know it's going to be a bit tricky. So there's O. So we know that O contains the left and right of our object. So if we were looking at our plan, yeah, okay, so to find, there's 1, I presume. 1, 2, 3 is here. And then you can see our curves actually have to come together. Right. That doesn't need to be freehand as far as here. It's just a freehand. Right. So the freehand curve goes from those on O to 1 all the way around. So let's put that in. Okay, so that's a freehand curve. And then, so we have O, lovely, and then that goes from, so we should look at the right hand side, that goes up to there, like that, and similarly on the other side as well. Okay, so there you are. So that's the curved surface there. And so what I'm after drawing there is, so what we're looking at here is this curved surface here. Okay, so that's what we're after doing there. Should that be a freehand curve there? No, because the freehand curve starts at O. So you see it starts there. That's the curve, it starts there. So the actual curve up here only starts up here. Yeah. Okay. Now, so we're nearly there. We're nearly there. The last part we need to do is this development of, or determine the true shape of surface S. Okay, so what we're going to do, what we're normally presented with for these questions is we'll get surface S the way it is here in elevation, and you'll get it as an entry on plan. It's what we're normally used to. It's the exact same procedure. We're just going to use the rebatment method, and we're going to flatten surface S down. Okay, and then we're going to basically, yeah, so we're going to use our widths in our plan, and we're just going to try to find the true the true length of it almost. So this edge here. Alright, so we're just going to flatten that down, and that's going to allow us to find it then in plan. So compass. So what I did first was I brought out a horizontal line here. Alright, and from the bottom I'm just going to flatten down surface S. So flattened it down like that. So rotate it around down, and then when you hit that horizontal line you just drew, you're going to bring that vertically down. See what I did there? So I flattened that down, brought that down around onto the horizontal line I drew out from here, brought it down, and what we're actually just going to do, because we have our widths, we can just because we have our widths, we can just use those to draw the true shape of surface S. So it's not much bigger, the true shape, but we still need to be able to show that we can do the construction. Okay, and then what I'll do is I'll actually put it in green. Alright, so that's the real true shape of surface S. Okay, so what we did again was we put a horizontal line out here, rotated, so this is surface S here, we rotated that down until it hit that horizontal line, brought that horizontal line down, and then where that hit the narrow part of surface S, that horizontal edge, we just joined from there out. Alright, so you can see there's not much in difference here. Just because I'm using a fine liner, it's going to be, my lines are a bit thicker, but there is actually, can I bring it closer to you? So if you look at surface S, look at the top especially. Alright, so there is a difference, and it is extended on in length. Alright, you can see the length is after extend. So what we did is rotate that down around, bring it down to our plan, and where it hit that narrow part of surface S, that's our true shape. So that's what we did up there, rotate it down around, brought it down to our plan, and extended it on. Okay, so there you have it. That's question 1. We've all our hidden detail here. We're fine there. Yeah, that's everything. I'm just looking at the question, just make sure we have everything. Yeah, that's the true shape of surface S. Yeah, so that's question 1, orthographic projection. Yeah, and I'm just going to number these just to show you where these points came from. So there's 1, 2, 3, 4, and 5. So the procedure again for finding this curve is 60-30 in your elevation, bring your points across where to hit this slanted edge, bring them down to your plan, and that's where you'll find them there. Any questions, feel free to ask me. Yeah, that's everything. So that's question 1 of the DEB paper. Alright, so that's mock 2. Thank you.